day, guys. Today we are looking at standard deviation in mathematics level 4. So we have given us this small data, which is what is always done with maths level 4. They give you very little data because they want you to go through the process of calculating the standard deviation, showing all your workings with all the formulas. Normally, you can just put this in your calculator, it generates the answers for you, but I don't want that. You see, they've insisted here that you show all workings because they want you to take us through every single step. So to calculate standard deviation, we need three simple formulas. The first one is the formula for the mean, which we usually represent it as x bar, and that is equal to the sum. This sign stands for the sum. Sum is addition of our x values divided by n. So xi means this is like x1, x2, x3, x4, x5, x6, x7. So that's what it means. So to calculate the mean, I'm adding up all my x values, which is 60 plus 42 plus 25 plus 34 plus 51 plus 42 plus 54 again. I divide by 7. You see it's x1 to x7. So if I do that on my calculator, it will take me to the mean. So when they talk of showing all the workings, this is what I want to see because I want you to understand how these formulas are working, not just putting them in the calculator and seeing answers. So I'm taking 60 plus 42 plus 25 plus 34 plus 51 plus 42 plus 54. That gives us 308. We divide by 7. Our answer is 44. So we've succeeded to get our mean as 308 on 7, which is 44. So that is our first formula that takes us to the mean. The second formula, this first formula is formula number 18 on the level 4 formula sheet. The second formula is that of the variance, which is formula number 19. It is defined as the sum of xi minus x bar, which means you take every data point there, you subtract the mean, then you divide by n. So if I have to express that out, it means I will take my 60 minus 44, 44 was the mean, plus 42 minus 44. If I don't have enough space to write all the numbers, you're allowed to put 3 dots like that. Then you capture the last number, which is 54 minus 44, all that square, and divide by 7. So we are going to take our time in the calculator and go through the process. So we're going to do that. We'll take our 60, the first entry, minus 44, you square it, plus the second entry is 42 minus 44, you square it, plus 25 minus 44, our mean will square it, plus 34 minus 44, we square it again, plus the next entry is 51 minus 44, we square it. I've made a mistake with that one, minus 44, we square that, plus we take another 42 minus 44 and square that, plus the last one is 54 minus 44, we also square it, so that gives us 874. So I'll take 874 divided by 7. If I divide that by 7, it gives me 124,857. So that is my variance. Just by looking at my formula and interpreting it, I can calculate my variance like that. There is also another option of calculating the variance. We call it the table method, where you look at the numerator of this formula, you use it to create a table. So if I'm doing that, I will have a table of 3 columns. The first column is my x values. The second is xi minus x bar. That is the second column, which means I'm now using that portion. Then the last one, I square every entry from the second column. So my data point are 60, 42, 25, 34, 51, 42, and 54. So those are my data points. Then I need the total of the middle column and the last one. So in the middle column, I'm taking every entry minus the mean, which is 44. So I take 60 minus 44. That gives me 16. If you take 16 square, I guess it is 256. Then 42 minus 44 is negative 2. You square it is 4. 25 minus 44 is negative 19. If I square negative 19, I get 361. 34 minus 44 is negative 10. I square negative 10 is 100. 51 minus 44 is 7. You square 7, you get 49. Then 42, we've seen that before, it will give us negative 204. 54 minus 44 is another 10, you square it, it's 100. So, usually the deviations, this middle column is showing you the deviations from the mean. So usually if you have, make no mistake, this total here must be 0. So for example, if you look at it, you will see that negative 10 will take care of negative 10, or maybe we can say 10 plus this is 17. 17 plus 16 is 33. So if you now take this one, so it's negative 29, negative 31, negative 33. So you see, the negative numbers go to negative 33, the positive ones go to 33. So that gives you 0. So let's now add up the numbers here. 100 plus 100 is 200, 204, I get 204, plus 49, plus 365, plus 365, then plus 256. So that gives us exactly 874. So the table is developed using the numerator of the formula for the variance, which is that one. So it's supposed to lead us to the same 874. So that therefore tells us that our variance is 874 over 7, which should lead us to the same 124, 857. So we are done with the variance. We can therefore look for the standard deviation, which is simply the square root of our variance. Take the square root of 124, 857. That should lead you to your answer. Square root of 124, 857. It leads us to 11,174. So guys, this is how we calculate the standard deviation, showing all the workings. So as I've said before, this can actually be done by just putting these figures in the calculator, and it gives you answers if you are good with your calculator. But for maths level 4, they expect you to show us how these formulas are working step by step. So these are the steps we expect you to follow. You calculate your mean first, you go to your variance using this formula, or using the table, then square root of variance gives you standard deviation. Let's now go to the interpretation of the standard deviation. When you calculate the standard deviation and see your answer, you must know what does it mean. Usually standard deviations that are bigger than 5 are considered to be large, smaller than 5 are considered to be small. And when your standard deviation is large, it simply means that your data is spread out. What do we mean by your data is spread out? Well, simply what it means is that most of your data points, your original data there, most of the data points are far from the mean. Your mean is 44. If you compare 44 to 60, it's far. 42 is close, but 25 is far to the left. 34 is far, and so on. So when you look at it, you see that most of them are far. It's only 42 that is close. Those who use the table method, they will see it better. You see, in the table method, the deviation shows you who is close and who is far. If the difference between the data point and the mean is between -3 and 3, it shows those who are close. You see, only 2 are close, which is the 42. The rest are big numbers. This is 16 units to the right, 19 to the left, so it shows that 60, 25, 34, 51, and 54 are far from the mean. So when most of your data points are far from the mean, the standard deviation is large. If they are close to the mean, the standard deviation is small. So my interpretation is that most data points or data values, if you prefer values, are far from mean. So that is what it means for me to get a large standard deviation. Or you simply say data is spread out. Data is spread out. So that is your interpretation. So guys, that's how easy it is to calculate standard deviation and interpret it. We'll do the same thing with this other simple exercise. So we're responding to the same question. We need a standard deviation showing all workings. So we start with the A part, which requires us to calculate the mean. So I get a 7 plus 4 plus 9 plus 4 plus 9 plus 5 plus 4 plus 6. All this divided by 1, 2, 3, 4, 5, 6, 7, 8. This time we've got 8 data points. So if I'm adding this point, this is 11 plus 9 is 20. Then 9 plus 9 is 18, that is 38, plus 10 is 48. You see the data is so easy that I can even calculate without the help of a calculator. And that gives me my mean as a 6. So from here, I can now go to the variance. The variance, its definition, as we've seen before, is the sum of every data point minus the mean, all that square, divided by n. So what does that mean? I take 7 minus 6, the mean square plus 4 minus 6 square plus, if I don't have time and space to write everything, I can switch to the last one, minus the mean square divided by 8 because I've got 8 data points. So this data is actually very simple. We can actually work without using a calculator. If I take 7 minus 6, it's 1, 1 square is 1. 4 minus 6 is negative 2, you square negative 2 is 4. 9 minus 6 is 3, you square 3 is 9. 4 minus 6 will still take us to 4 like the other one. 9 minus 6 will still lead us back to 9. Then 5 minus 6 is negative 1, you square it is 1. 4 minus 6 is negative 2, you square it is 4. 6 minus 6 it is 0. Divide by 8. So if you calculate the numerator, this is 10, 14, another 10, 14, that's 28 plus 4 is 32, 32 on 8 gives us a variance of 4. So if you also wish to use the table method, it's still not a problem. Both of them were very easy because this data is so friendly. So as I've told you, the main purpose for doing this in level 4 is just for you to understand how the formulas are working. If we start going to large data, we just use calculators or computers to do that for us. So we have 7, we've got 4, we've got 9, we've got 4 again, we've got 9, we've got 5, 4, and 6. 2, 4, 6, 8. So that's our data. We subtract the mean from each of the data points. 7 minus 6 is 1, 1 square is 1, 4 minus 6 is negative 2 square is 4, 9 minus 6 is 3, 3 square is 9, then 4 again leads us to 4, 9 again leads us to 9, 5 minus 6 is negative 1 square is 1, 4, we've seen it before, will lead us to negative 2 and 4, 6 minus itself is 0, 0 square is 0. So if we take the total, we expect the middle column to give us 0 if we didn't make any mistake. This is 1 plus 3 is 4, 9. So that is 9, and this is negative 3 minus 3. Sorry, this is negative 3 minus 5. Negative 3 minus 3 is negative 5, this is negative 7, this one was what? 3 plus 3 is 6, 7, sorry, I was saying 9. 3 plus 3 is 6, 7, the positive numbers are 7, the negative is negative 2, negative 2, negative 2, negative 6, minus 1 is negative 7 also. So the total then must be 0 if we didn't make a mistake. Then we will go to the column that is going to represent the numerator of your formula. If you add this, this is 9 plus 4, this is 10 plus 4 is 14, another 10 plus 4 is 14, 14 plus 14, 28 plus 4 is 32. So this data is so friendly, we don't even need a calculator. So therefore your variance again is 32, over 8, which leads us to 4. And that will show to us that our standard deviation is simply the square root of 4, which is a 2. So guys, that's how we do the A part, and now we can interpret it. So if we're interpreting our standard deviation, you see this number is quite small. As I told you before, standard deviations below 5 are considered to be small, above are considered to be high. So if this is small, how do you interpret it? The small standard deviation tells us that most of the data points are close to the mean. If you check, your mean is a 6, your standard deviation, your mean is a 6, the data points are here, 7, 4, all these numbers are close to the mean. You can even see in the deviations that deviations are just between -3 to +3. Those are your deviations. Those are very small deviations. They are just telling you that this number is just 3 units to the right side of the mean. This one is 2 units to the left. So they are numbers that are quite close to the mean. So expect a standard deviation that is small. So that is our interpretation. So I will say my data is clustered around the mean when I have a small standard deviation, or most data values are close to the mean. So guys, that is the simple exercise about standard deviation. Thank you very much.